Oh, it's so cold outside today. It's like 5 degrees. Good thing I have this boiling hot coffee to enjoy. But I like my coffee at 68 degrees. I wonder how long it's going to take for it to get to that temperature. Oh yeah, it's been 5 minutes. This definitely feels like it's at 90 degrees right now. I wonder how long it's going to take for it to get to 68.
So, Newton's law of cooling. First you have to know that the rate at which an object is cooling or warming is proportional to the difference between the temperature of the surrounding and the temperature of the object. So we can set up a differential equation. We have d temperature over d time proportional to the difference between the object and the surrounding. You have a separation of variables. You put this entire chunk over to the left side and dt over to get this. Integrate both sides. Do some algebra. Here you get e to the power of kt plus c. C is just a constant, so we can combine this into c e to the power of kt. So this is the first equation we have, and then we can pretend at time 0 we have t, plug in 0, so it's e to the 0, so that's 1. So c is equal to t naught minus t surrounding, and then you can plug this into the c here to get t minus t surrounding is equal to t naught minus t surrounding times e to the power of kt.
And so you might be wondering, what do these variables represent? So I'm going to go over each one. So the big T means the final temperature. Ts is the surrounding temperature. To is the initial temperature. Ts is again surrounding temperature. E is the Euler's constant. K is the proportional factor, and T is time. Okay. So since we know that it took 5 minutes to cool down to 90 degrees, our final temperature is going to be 90 degrees. Surrounding temperature is going to be 5 degrees. It was boiling, so it was originally at 100 degrees to start with, our initial temperature. Our surrounding temperature again is 5 degrees Celsius. Okay. We have an Euler's constant here. We don't know our proportional factor, so that's why we're going to figure that part out. And then we have our time, which is at 5. Okay. So we do simple subtraction. 90 minus 5, 85. 95 E5K. So now we use algebra to figure out what K is. So K is equal to ln 85 over 95 divided by 5. Okay. Now that we have our K factor, we can solve for the actual time it will take to cool down to 68 degrees. So we follow the same equation and we figure out that time is equal to 18.464 minutes.
I got it. So the answer is 18.464 minutes. Hello? Hi. Oh, you need some calculus help at the park? Yeah, I got 18.64 minutes. I think I can help you. Oh no, it's not going to take me a long time. Since you're not moving, the only thing changing is the distance between us. So it won't take long. I'll see you, bye. Oh, my friend's right up there. Oh, this hill is so steep though. Oh, definitely greater than 2.6. calculus help?
Yeah. Can you explain to me the mean value theorem?
Oh, the mean value theorem. Well, do you have a set of keys?
Oh yeah, I do actually.
Well, as you see, if I just throw these keys behind me, I won't know exactly where they are, but I'll know that they're there.
Oh, I see.
So, is that all you had for me?
No, I wanted to ask you about the limits. Can you explain to me the limit?
Oh, the limits?
Yeah.
So, what did you need help with limits?
Oh, I just don't really understand like the concept of limit. Like, could you explain to me like this basic concept of limits?
Well, I'll give you an example. Let's say we have this coffee right here.
Okay.
Now, if I drink half the coffee each time, I'll never run out.
Could you explain that a little bit more?
Well, if I drink half the coffee, I'll just be taking smaller and smaller sips each time, but I'll never actually run out since I'll only be drinking half.
Oh, damn.
You just do it?
Turn down for what?
This is the function, and this is the area of the function. This is the area under the function. We call this the integral. Alex, do you know how to find the area under the function?
No, I do not. So if I'm trying to find the area under the function,
Yes.
what am I supposed to do?
You're supposed to find the integral of the function.
What's integral? I haven't learned integral.
Do you only know derivatives?
I know derivatives.
Do you have a cumulative test coming up where you only know derivatives?
I'm writing it right now.
Oh, you have to pick D.
Pick D.
Pick
Okay.
D.
I trust you.
Turn down for what?
Okay, good.
Wow, thanks for your help. I really appreciate it.
Oh, no problem, anytime.
Well, I'm gonna go study for my test now. I'll see you later.
Who does that? Let's just go play poker.